All right, everyone. So today I'm going to go over the mid-segments, medians, and centroids section of our notebook. So the first thing we're going to go over is mid-segments. And first of all, the definition of a mid-segment is a segment connecting the two midpoints of two sides of a triangle. So for example, if we look here at our image, we can see that D is the midpoint here of segment BA because we have the congruent tick marks, and E is the midpoint of segment BC because again with the congruence tick marks. For the mid-segment theorem, it says that if a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and half as long. So using this diagram above, we want to go ahead and mark the two segments parallel. Do that. So your first inclination when you're looking at an image like this is highlight any congruence tick marks and then mark any sides that we know to be parallel. So if segment DE is a mid-segment, then we can conclude that segment DE is going to be parallel to segment AC. We can also make the conclusion, because remember it says that this midpoint, the mid-segment is half as long. So we can express this two different ways. One thing we can do is say that segment DE is equal to segment AC divided by 2 because it is half the length of the parallel segment. Or we could say that AC is equal to 2 times the length of DE. Either will work depending on what you're needing to do. So let's look here at a few examples. I am going to be highlighting each section. So first off, it says to identify all pairs of parallel segments in the images below. So I'm going to start here with segment QS, and I'm going to highlight XY. Now again, because I have these congruence tick marks, this one right here and this one right here, I can tell that these are going to be parallel because I also have these congruence tick marks. So this is what's telling me that XY is a mid-segment. So then again, I'm going to go ahead and highlight QR and the corresponding mid-segment of WY. And then finally RS and the corresponding mid-segment. And then here I'm going to go ahead and make a list. So the first thing I'm going to put is segment QS and XY are parallel. And then we have segment QR and segment WY are going to be parallel. And finally, we have segment RS and segment WX. And then we're going to do the same thing for triangle FGH. So again, first thing I'm going to do is make a note of all of my parallel segments. So first off, I'm going to notate my congruence tick markings, which will allow me to make the claim that JK and L are all midpoints of their respective segments. And then we have GF with segments GJ and JF is going to be parallel to KL. We have FH parallel to JK. And finally GH is going to be parallel to JL. So let's go ahead and write that down. On the next example, we are going to go ahead and add the congruence tick marks and the highlighting. So the first thing I'm going to do is add the congruence tick marks based on given information. So if I look here, it says if L, M, and N are the midpoints of the sides. So I'm going to go through and mark L as a midpoint. I am going to mark M as the midpoint of QR. And then I'm going to mark or sorry, N as the midpoint of segment PR. And I'm doing this using the line tool, making tick marks. Okay. Now, because I have made that notation, I can then say that LN is a midsegment parallel to QR, which means it is going to be half the length of QR, which means it is the same length as MR or QM. Same thing for segment MN, because it is the midpoint to midpoint. So it is going to be one tick mark, just like LQ and PL. And finally, the third side, LM, is also a midsegment. So that means it is parallel to PR, congruent to PN and NR. This is good information to have. Then I'm going to go ahead and color code the sides. I put in those tick marks. I'm going to highlight them. Notice I'm doing all of the tick marks. And then I'm going to highlight the sides as well in a different color. All right, so now what I'm going to do is use the relationships between the sides to determine the missing lengths. So first off, it gives me that PR is 46. So again, I'm going to go ahead and color code that information by underlining it. PQ is 40. And LN is 17. Now the missing side length, we have LM, which is the midsegment that is parallel to PR. So all I will do is take PR and divide it by 2. So I'm going to use my formula tool, and I'm going to put in my division symbol first because that makes it a little bit easier to do PR over 2, which would be equal to 46 divided by 2, which is going to be equal to 23. All right, MN, which is the midsegment that is parallel to segment PQ. So again, that's going to be PQ divided by 2. Again, because we're finding the length of the midsegment, not the base. 40 divided by 2, and that's going to be 20. To find the length of segment QR, we can see that's the base that is parallel to segment LN, midsegment LN, which we were given as 17. And so for this one, it is fairly simple. We're going to say that QR is equal to 2 times LN. And so that means it is 2 times 17. Therefore, the answer is 34. And finally, we see that MR is half of the base. It is congruent to LN. So I'm going to say that MR is equal to LN. So therefore, it is going to be equal to 17. Finally, on this page, we are going to look at a triangle here and solve for x. We have congruence tick marks here and here. So what that indicates to me is this segment here, the 7x, is a midsegment because it connects the midpoints of 2 sides. So it is parallel and twice the length of the parallel base. And for this problem, we are going to multiply the midsegment by 2, simply because 17x does not divide evenly by 2. So we're going to say 2 times 7x is going to be equal to 17x minus 18. Now I know normally I do try to avoid negative x's, but because 2 times 7 is 14, and that is on the right side of the, left-hand side of the equal sign by itself, I'm going to end up simplifying my equation by subtracting 17x from both sides. So that's going to leave me with negative 3x is going to be equal to negative 18. We will then divide both sides by negative 3, which will leave me with a final answer here of x is equal to 6. Okay, so our next part is going to be medians and centroids. So the definition of a median is a segment joining a vertex to the midpoint of the opposite side. So we're going across. And I'm going to go ahead and highlight these words by highlighting it and then selecting the background color. And I just picked a very light background color. So again, anytime we see congruence tick marks, we should go ahead and notate them. A centroid is the point where the three medians of a triangle intersect. Okay, so it's a point and the three medians intersect. It's where they cross. So if we look here on our image, we can see that the point where they intersect is P. So that is going to be the name of the centroid, P. Now the medians are BF. So these are going to be segments. So I'm going to use my formula tool. So we have segment BF. We have segment AE. And we have segment CD or DC. Now there are some special properties for medians. These apply to all of the medians, but we are going to be focusing on segment AE as we write these equations. And again, we know this is a median because the congruence tick marks. We go from a vertex to the midpoint. Same thing here, vertex to midpoint to D, and B to F. F is the midpoint. So the special characteristics, and again, we are going to be focusing on segment AE for this one. So the first special characteristic is AP. I'm going to make this. AP is equal to 2 times the length of PE. So what that means is this segment here, I'm going to highlight it, from P to E is going to be half the length from P to A. So this one here and this one here. So AP is twice the length of PE. So that means BP is twice the length of PF. PC is twice the length of PD. And you can also say that PD is half the length of PC. PF is half the length of PB. And PE is half the length of PA. So let's go ahead and represent that one as well. So PE is equal to AP divided by 2. The next one is going to be based on the relationship AE, the whole segment to each portion of it. Okay, so the next relationship is that segment AP is 2/3 the length of the full median AE. So the same thing again applies. BP is 2/3 BF. PC is 2/3 CD. Finally, the converse applies as well. So AP, PE is going to be 1/3 the length of AE. Okay, so PE right here is 1/3 of the total length. So you can imagine that a median has been cut into 3 pieces, the length of PE. 2 of them are in PA, and the third one is in PE. So the centroid is 2/3 of the length of the median from the vertex, so AP, 2/3 of the distance from vertex to midpoint, and that's the centroid, and then 1/3 of the length to the median, or to the side. So let's do some practice with this. If P is a centroid, so that's a very important piece of information, so let's go ahead and highlight that. JK is 22, KN is 13, and OL is 18. So the first thing we're going to do is mark our congruence tick marks. Because P is a centroid, that means that each of these segments that are intersecting here at P are medians, which further means that each of these is divided in half. So M is the midpoint of JK, N is the midpoint of KL, and O is the midpoint of JL. So this is us using the medians to find side lengths. Right? So first off, they give me JK is 22. They tell me that KN is going to be 13. It's going to be on this whole side. And OL is 18. And we're going to find each measure. So then we're going to look here at KM. KM is half of JK. So we're going to go ahead and put that in our formula tool. So JK divided by 2 will give us KM. And JK is given to us as 22, which if we divide by 2 is going to be 11. So KM is 11. NL is going to be the same as KN because we see they're marked congruent. So NL is equal to KN, which means it is going to be equal to 13. KL is the full side length, and so therefore it is going to be equal to 2 times the length of KN. So that's going to be 2 times 13, which will give us 26. Right? JO is congruent to OL, so we can just say that the segment lengths are going to be equal. So therefore JO is 18. And then JL is the length of the entire thing. So it is 2 times the length of OL, which means it is 2 times 18. And 2 times 18 is 36. Okay, for the next one, we are again given the centroid. If X is the centroid of triangle RST. So again, I'm going to go ahead and highlight my centroid directly. And let me go ahead and do it in a different color. It then goes on to give me TU, SW, and RV. So in this case, we are going to be looking at the medians themselves. So let's go ahead and highlight them. So again, we have TU, which is 27. We're going to TU. And then we have SW, which is another one of our medians. So vertex S to midpoint W. And finally, we have RV, which is 21. And again, it tells us that it's the centroid. So again, it would be a good idea to mark our congruent tick marks. 2. So TX. TX is the longer portion of the full segment. So we are going to say TX is equal to 2/3 the length of TU, which means we're going to take 2 over 3 and multiply that by 27. You can run that through a calculator, but 27 divided by 3 is 9. 9 times 2 is 18. But just to show you that I'm not making things up, 2 over 3 times 27 is 18. Right, our next one is XU. Now we could do XU is 1/3 of TU. 27 divided by 3 is 9. We could also say that TXU is half of TX. So either of those options is correct. So I'm going to say 1/3 TU, which is equal to the same thing as TX. I'll put both of these in here. So TU is 27 times 1/3. 1/3 times 27 is 9, like I said. And then, or we could, like I said, we could have TX divided by 2. And since TX is 18, divide that by 2, and we still get 9. So either way you choose to do it, the answer is still 9. All right, next one they asked me for is SX. They give me 18 as SW. So again, we are going to say SX is the longer of my 2 portions of my centroid, or my median, sorry. So it's 2/3 SW, which is going to be equal to 2 over 3 times 18. And 2 over 3 times 18 is 12. And then XW, again, we can do it either of two ways. We can point out that XW is 1/3 the length of SW, which means 1/3 times 18, which is 6. Or, again, you can have XW is equal to half of SX, so SX divided by 2, and that means we're going to have 12 divided by 2, and again we still get 6. You would only ever have to show me one of these on an assignment, but it's never a bad idea to include both in your notes. Finally, we have RX. RV is given to us as 21, which is again the full length of the median. RX is the longer half, so again we're just going to have 2/3, so 2/3 times RV, which is going to be equal to 2/3 times 21, which should be 14. And if they wanted us to find XV, we could just divide 14 in half and get 7. For this last set, we are going to be mixing that information from both of the previous two problems. So the first thing it tells us is that H is the centroid of triangle BDF. So again, I'm going to highlight that statement, and then I'm going to highlight the centroid. And since it is a centroid, that means each of these segments goes from a vertex to a midpoint. So the first thing I'm going to do is mark segment DC congruent to segment BC, segment DE congruent to EF, and BG is going to be marked congruent to segment GF. And then, of course, just like in the previous problems, I am going to go ahead and highlight each of the medians that go through the centroid. So we have BE, we have DG, and we have FC. And let's see what information we're given. DF is one of our side lengths, and we're given to us as 50. CF is one of our centroids, our medians. And BH is part of a median. So let's go ahead and look at these different parts. So first off, it asks us for HE. HE is part of the segment BE. It is the smaller portion. So we are going to say that HE is half of BH, because they gave me BH. So we're going to divide BH by 2. BH is 22 divided by 2, and that gives us a length of 11. Now I am going to go ahead and skip over here to problem F, because it asks me for the length of BE. Well, BE is the full length, okay? So we could say it's HE plus BH, 22 plus 11. We could say that BE is 3/2 times BH, because in order to invert the fraction, we would have to flip it. So what I would do, though, is say that BE is equal to BH plus HE, and that's going to be 22 plus 11, which is 33. I am going to actually show you, though, we could say that BE is equal to 3/2 BH. So we'd have 3/2 times 22. I'm going to highlight that and put it through the calculator. We get 33. So either way, but personally, I would use the knowledge that the two segments can be added together. Next, it wants us to find EF. EF is part of segment DF. It gives me DF is 50. So we are going to say that EF is half of DF, because E is the midpoint. And so therefore it is 50 divided by 2, which is going to be 25. HF is part of the CF median. We also have DE, sorry. Do DE first. DE is congruent to EF. HF. HF is the larger portion of this median CF. CF is the full length. So we are going to say 2 over 3 times CF is going to be equal to HF. So it's going to be 2 over 3 times 42. And we get 28. And then it asks me for CH. Again, we can do CH two ways. We could say that CH is going to be 1/3 CF. 1 over 3 times 42, which is 14. But we can also state that CH is half of FH. So we can say FH divided by 2. And that's going to be 28 divided by 2, which is still 14. So either of those options, again, would work. Right, so that's all I have for you right now. Make sure you get this filled in completely because you will need this information for the test you have next week. Until next time, stay safe. Bye.